Here is another free fall problem. This one is slightly different than the one where the rock is being dropped because in this situation the baseball is being thrown off the bridge. So the initial velocity will not be 0. In this case it'll be 15 meters per second. And I should also clarify, we're saying that we're throwing this down off the bridge. And a lot of times we say that down is the negative direction. I'm choosing to make this positive because the ball or the baseball is only falling. I'd rather not deal with negative numbers, so accordingly I'm going to make my acceleration 10 meters per second squared because gravity is pulling down, so its direction will be the same as the initial velocity. They'll both be positive. Alternatively, I could make those both negative if I wanted to, but I think it's easier to consider them positive. Alright, so again, we're trying to figure out how far this thing falls. So if this thing is falling for 2.3 seconds, we want to know how fast it is going when it hits the water. So what we have to say to ourselves is every second that it's in the air, its speed changes by 10 meters per second. Again, that is the definition. That's what acceleration from gravity is. So if it's in the air for 2.3 seconds, if we multiply that by 10 meters per second, we're going to get a change in velocity of 23 meters per second. And I used essentially this equation here, although I didn't actually plug into the equations, kind of used, what made sense based on what acceleration is. But if you wanted to, you could plug in 10 for A and the time here and solve for delta V. That's the same thing I got here. So the velocity changes by positive 23 meters per second. So if it was going 15, if I add that to 23, it will be going 38 meters per second when it hits the water, if that works out. So the average velocity is just the average of 15 and 38, so I add them up and divide by 2, and it's 26.5 meters per second. So the average speed during the entire fall is 26.5 meters per second. And it falls for, I forgot to write this down, 2.3 seconds. So I can basically use this equation if I like and say, all right, well, it is going 26.5 meters per second for 2.3 seconds. So I say, how far is that? If I multiply these out, I get 60.95 meters, which I'll probably round to 61 meters if we consider significant figures. So it falls 61 meters in 2.3 seconds. So it's almost the exact same as the thing being dropped. The only thing that changes is that my initial velocity is no longer 0. I have to, make one small adjustment for that. But otherwise, it's almost the exact same problem. So until next time, I am Derek Genova. Have a delightful day.